Alright, so let's look at Hamming code error correction and its visualization. So, to begin off, we need to understand the concept of a parity bit. So let's say we have the data of 1010001. Now we can see that this data, I'll highlight in blue here, has 3 ones, right? And if we wanted to make it even, we need to add a 1. So that is going to be our parity bit, right? So if we wanted to make it even, we need to add a 1 to it. Notice that we're focusing on the ones. Alright, so if we look at our outcome here, we'll see that we've added our parity bit at the end here, right? So it became 101000011. Now let's look at another example here. In this case, we have 1, 2, 3, 4 ones, correct? And what do we add to this? We're going to be adding a 0 because the ones are already even. So we can see that we add a 0. So in this case, we can see that these bits that we're adding at the end are our parity bits. Now let's move on to the visualization. Let's say we had data. In this case, we have 4 bits of data, and we can see that it is 1100. So I've labeled some stuff on this Venn diagram here, and we're going to be using the 7-4 Hamming code method for this, right? So this Venn diagram relates to the 7-4 Hamming method. So let's get to it. So you can see that my labels here, D1, D2, D3, and D4. That represents the bits of data that we have. And P1, P2, and P3 represent our parity bits in this case. So let's find our parity bits once we input in our data. So let's put in 1 for D1, 1 for D2, 0 for D3, and 0 for D4. So like that, we've inputted our parity bits. Sorry, our data. So now let's find our parity bits. So to find our parity bits, all we have to do is analyze each circle here. So for P3, we just have to focus on this over here, right? All we do is focus on that. Okay? So we have to see what is going to make our ones even here. So we have 1, 0, 0, and we know that if we add a 1, our ones will be even. So 1 is going to be my parity bit in this case. Now let's go to P2, which covers this area. And we can see that our data has 1, 0, 0. So what should I add here? I should add a 1. So now my ones are even. Now let's look at P1, which is our final parity bit. And we can see that in that little sector we have 1, 0, 1. Now for here, we will have to add a 0. This is because our D1 and D2 are 1s. And we already have an even number of 1s. So now let's move on to error correction. So now let's say we were to have an error. So let's erase one of these datas that we have, or data bits that we have here. So let's get rid of D3 in this case. And let's say instead of a 0 there, we were to put a value of 1. So how would we know that there's an error there? Okay, so the way to do that is to actually see if everything's going right. So let's look at the parity bit 3. Start here. We can see that we have 1101. Again, that's instantly an issue because we have an odd number of 1s. So I'm gonna make a little X here saying there's an issue with this one. Now let's go to the second parity bit, and we'll see that we have 111 again, which is not good. There's an odd number of 1s, so we're gonna make an X here. So we have an issue there. Now let's go to our first parity bit, which has 2 zeros and 1 1s, so no issues there. So that means our issue has to be in a place where these two parity bits overlap. And the only place that happens here is D3. Right? Just these two. Not P1, just P2 and P3, right? So in that case, it would just be D3. And we would just switch it to a 0 in that case, if we wanted to fix it. To confirm our understanding of this concept, I have changed one of the data values and we're going to be finding the error. All right? And I have not highlighted it this time, so it's a little bit more difficult. So let's look at parity bit 2 first. All right? We can see that everything looks really normal here, right? We have 1 and 1, 0 and 0. Everything looks phenomenal. Now let's go to parity bit 1. And here we can see a little bit of an issue. We have 3 zeros and 1 1, which just shows that our 1 right now is odd. So that's not good. So I'm gonna make a little X over here, right? I'm gonna make a little X. All right. Now let's go to parity bit 3. Here we can see there's another issue as our 1 is odd again. So now we just have to find a place where only parity bit 1 and parity bit 3 overlap, which in this case is D1. So all I have to do to fix this is to switch it to 1. Let's do that. And that should fix it. And let's make sure it fixes it. Yes, it does. So we have even number of 1s, even number of 1s, even number of 1s. Everything is good. So that's it for Hamming code error correction. Hope this video helped. Have a good day.